All right, so day 2. Yesterday we talked about the syllabus and we talked about the goal setting sheet. So you know the expectations of the class, and you did your goal setting. You turned that in. Today you turned in your student info sheet. Everything's great. And today we are going to be talking about invisible math. Now you'll notice at the top of the screen we have a learning target. I can't identify and apply properties of invisible math properties. Okay, invisible math properties is what I should have said. My bad. And then we're gonna figure out the smart pass eventually on restroom. Okay, today's Tuesday, so Thursday during your lead time there should be more information. Okay, so let's talk about this. So, does everyone have this sheet, invisible math? Okay, so we're gonna fill it in as we go. So let me put this over. Cool. All right, so invisible math. Like it sounds, it's invisible, okay? Meaning it's stuff that's there, it's implied, but we don't always write it, okay? Now, do y'all see this poster here and over here? Okay, these are posters that talk about invisible math. So after today, if you're trying to remember some of the stuff we talked about, it'll be on that poster, okay? But I'm gonna think a lot of this stuff you may already know, so it shouldn't be too hard, hopefully, okay? First things first. The first thing says 3 equals 3 over what? It's 1, okay? If you didn't know that, any whole number can be divided by 1 and turn it into a fraction, okay? Now, do you always write divided by 1? No, but it's there, technically. So go ahead and fill this in. So this equals, sorry. Oh my God. So 3 divided by 1, okay? Cool. And so there is a denominator. Do y'all know what the word denominator means? We have heard on a fraction, the top is the numerator and the bottom, or when you go down, it's the denominator, down denominator, okay? So there is a denominator of 1 for every number. Every single number can be divided by 1, stays the same. It's invisible math. Next one, there is a decimal point at the end of every whole number, okay? No problem. You're good. Do you have you can say wherever. Do you have a student info sheet signed from yesterday by chance?
Oh, yeah.
So again, there's a whole number, sorry, there's a decimal point at the end of every whole number. So 10 really is 10.0, okay? Maybe you knew that. Hopefully you knew that. You don't always write 0.0, but you could, right? It's invisible math. That's why we call it that. There is a positive sign to the left of every number, unless there's already a negative sign. Right? So just like a regular 6 really means plus sign 6. But do we always write the plus sign? No, we don't. Okay? It's invisible math. So again, all this stuff is implied. It's supposed to be there, but we're not going to write it every single time because it can get out of hand. You know what I'm saying? You could always be putting pluses and 0.0s and too much. Now, there is a blank of 1 to the left of every blank. Now, check it out. In front of a variable, the letter x, do y'all know what you call a number in front of x? There's a name for it. Starts with a C. Coefficient, right? So this x has nothing on it, nothing in front of it. But I'm telling you, there's a invisible implied coefficient of 1 to the left of every letter variable. Okay. Boom. So there's always a 1 implied in front of a letter that's by itself, a variable. Okay. So let me make sure I'm clear on this. X does not equal 1, but x has a 1 in front of it. Okay? X is unknown, but there's a 1 in front of it. Okay, what if you have 2y, a number then a letter, a coefficient then a variable? Well, what's implied in front? There is a multiplication sign between every coefficient and variable. Now I'm going to show that with a star, but you can put a dot. You're multiplying 2 times y. So 2y means 2 dot y. And hopefully y'all know that already. Things that are just sitting next to each other mean they're multiplying. Cool. All right. A negative sign, now you're going to see this a lot. If you just see a negative sign in front of something, so in this case, to the left of a variable, okay, it is the same as a -1 times the variable. It's like -1 times. That's what you're doing. Negative x means -1 times x. Hopefully y'all can see that. Okay, 7 equals 7. Now we're talking about exponents. You see how that box is smaller? Okay. Every number has an exponent of 1. Okay. All right. Any non-zero, oh, my bad. Every number has an exponent of 1. So that means 7, a regular 7, means 7 to the power of 1. So are you always going to write 1 as an exponent for every number? You don't have to. It's invisible, but it's there. Okay. The next one. Now, what if it's to the power of 0? Now, what would you normally think? Something to the power of 0, you might think, doesn't it have to equal 0 every time? But that's only when you multiply by 0, okay? So when it's to the power of 0, it always gives you 1. Kind of weird, right? So like 7 to the power of 0 is 1. 79 to the power of 0 is 1. A billion to the power of 0 is 1. Okay, so that's kind of a weird one. You got to know. So any non-zero number to the 0 power is equal to 1. Ta-da! Cool. Every radical. So y'all know about square roots? A square root tells you how many times a number will multiply by itself, a total of 2 times, to give you that number. So a radical has an index, we call it, of 2, meaning a number times itself, that's twice, gives you what? So radical 8, square root of 8, means index of 2, 8. So there's other things besides square root. There can be a third root called a cube root. There's a fourth root, fifth root, forever, right? But normally, without a number, it means index 2, square root. All right, now, bottom of this page, 1 over x. 1 over a variable is the same as the variable to the negative first power, meaning x to the -1. Hopefully y'all can see that. 1 over x means x to the -1. So if you ever see a negative in the exponent, right? -1. That takes it and throws it underneath a fraction bar. Okay? The negatives can flip you across a fraction bar. That's what they do. All right. We good on this page? You can flip it over. We got a couple more, and I'll give you a little practice. Okay. All right, flipping it over. Now this is kind of new. We're not going to see this again for a while, but if you see those two vertical lines, this is called absolute value. Okay? Two vertical lines, absolute value. All that means is it stays positive. Okay? Imagine all the numbers, half of them are positive, half of them are negative, and if you turn all those negatives into positives, you end up getting a big V. Positive, 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 hit 0, come back up. Positive, positive, positive. Big V. Okay? That's what a graph would look like of absolute value. Absolute value never is negative. So optimistic. Okay? So that being said, what if you have a negative number in front of an absolute value? Okay? So if you have a negative number outside an absolute value symbol, it is the same as a -1 times the absolute value. Okay? -1 times. Okay? Anytime there's a negative just hanging out front, that means -1 times whatever it is. Okay? Negative. And so sometimes I like to draw the 1 there. It helps me see it. Okay? So -1, and then you multiply. Times. Okay. And it's actually the same thing below on the next one. There's a negative in front of a parentheses. What am I going to do? Well, that's -1 times whatever's inside. So even if we have a negative number outside of a number in parentheses, is the same as a -1 times the number in parentheses. So again, -1 times. On the next one, I bet you might have heard this before. There's a number in front of a parentheses. What do you do with that number, and what do you do to the parentheses with that number? Any ideas? Good. So it multiplies into the entire parentheses. I like to show it like this. Draw this. 2 times x, 2 times 4. What is that property called when you do that? Distribution, distributive property, however you want to say it. Distributing, all these ways of saying it. Use the distributive property. Okay, so it's going to multiply. So on this one, it's 2 times x. Now this one, it's 2 times 4. Well, 2 times x is 2x. 2 times 4 is 8. Cool. So use the distributive property, multiply the number outside the parentheses by each term inside the parenthesis. And last but not least, we've had 3 of these so far. If there's just a negative hanging out in front, it means -1 times whatever's on the inside. Okay, so I like to show it by drawing -1 times both of these, distribute it. So it's going to be what? -1 times x over here. And then it's going to be -1 times -5 over here. Now, -1 times x is just straight up -x, right? The -1, the 1 goes away, the negative stays. Now, what's a negative times a negative? Positive. That's a +5, okay? So here's the rule. Here's the trick. When there is a negative sign out front, outside the parentheses, the sign, plus minus sign of the terms inside the parentheses change. Okay. Negative here changes both signs. Every sign. So see how x was positive? Now it's negative. See how 5 was negative? Now it's positive. So do you have to really do this? And if you see minus sign in front, just change your signs. You're good. Okay? If you do this, you'll get the same answer. I'm just saying. The shortcut is negative out front, change all the signs in the parentheses. Okay, let's talk about the way you're going to see stuff in the class. Now, when you were younger, you probably saw multiplying with an x, right? But now you get to algebra, and now we actually use the letter x to mean something, a variable, right? So we're not going to usually see a x b for multiplying anymore. Normally, we're going to use the dot. A dot b means multiply, or a star b means multiply. Or obviously, like we've been talking about today, if they're just sitting next to each other, they're multiplied. If it's next to a parentheses, it's multiplied. Cool? Dividing, you're not going to normally see this way. This is old school, like long division. You're not going to usually see it with a dividing sign, though you will this week. Not a lot after this week. Normally, division is going to be a slash or a fraction bar, right? That's normally how we divide. And that's it for the notes, okay? So I'm going to pass out this little practice, okay? I often say this. I'm not cute. I don't like cutting things out and doing things that are, other teachers can do that. I'm just not that good. All right? So I'll just print it out on a piece of paper. Give you one thing to do. Cool? So if you can fill this in, it says equals, and there's a blank space for you to tell me what does that equal. There might be more than one answer, but think about what they're asking up here. Or what are they saying up at the top? You write the answer. Okay? There's only 8 of them. You can turn them in. No big deal. Cool? You can work together. I don't mind. Just make sure you put your name on your own paper and turn in your own paper. That's pretty much it. Cool? That's today's.